Welcome to another video for mathematics. In this video we're going to be discussing logarithms and the three different properties that you see here. We're going to be discussing quotient, product, and power property. I'll be working out three problems that will highlight each of these properties. So without further ado, let's take a look at your three properties we'll be discussing. The first is the product, which is what you see here. It can be written as log base b a times c equals log base ba plus log base b c. So as you can see here, you have an expanded form on the right and a more condensed form on the left. And then you have the quotient property, which is log base b a over c equals log base b a minus log base b c. So keep in mind that the log base must be the same for each of these. Each of these terms must have that same log base b. Now, whether you use product, quotient, or power property will depend on whether you have a plus sign or a minus sign. And the last one is your log base b a to the c power can be written as c times log base b to the a. Okay, so let's work out some problems where we actually get to work some of these out and see how it looks. So here's your first problem. It's pretty long. Okay, so one of the first things I want to point out is that they all have the same log base. Okay, they're all log base 7. 4 plus x plus 4 minus log base 7 of 2 equals log base 7 of x minus 2 plus half log base 7 of 9. That's a lot. It's pretty long. So I want to highlight first. Now with this one, I'm actually working backwards. I have an expanded form of this function, and I want to condense it into one term. So I'm going to be working backwards here. So you'll notice here I have two coefficients. I have a 2 and a half, and those coefficients, based off of my power rule, as you can see here on the bottom in yellow, those coefficients can go in as exponents. And that's what I've done in the next step. They've become my exponents now. I'm going to simplify these. So 2 squared is going to be 4, and then 9 to the half power is the same thing as 9 squared, which is 3. Now I'm going to put my attention to, on my left side, you can see here log base 7 4 plus log base 7 x plus 4. So we have a plus here, so that means I can use my product, and I can condense that from having a plus to now having one log base and then to a product, two products, 4 times x plus 4. Okay, and then as you can see here, I'm widening my focus, and I'm looking at that minus sign, because now with that minus sign I can actually use the quotient rule and divide 4 times x plus 4 divided by 4, right? So as you can see here, I'm showing my previous steps so you can kind of see what my thinking was as I'm going down the line. So I'm going to simplify that, and the 4's cancel out, leaving me with log base 7 times x plus 4. That's my left side term. Now I'm going to put my focus on the right side and simplify that, or condense that. So I have log base 7, and they're all the same logarithms. So I have the plus sign, so as you know, I can use my product property, condensing that 3 times x minus 2. I'm going to simplify that. Actually, before I simplify that, I have a little rule here, property of equality for logarithm functions, which means that since I have the same base, log base 7 equals another log base 7, and then some term, I can actually cancel those log base 7's out, leaving me now my x term, my algebra terms. And I can solve this algebraically now. Of course, on the right side I have 3x minus 6, and now I'm just going to isolate the variable x by doing a little algebra, subtracting. And of course, you can take a different approach. You don't have to follow exactly what I'm doing here, but I'm subtracting the 4 on both sides, leaving me with x equals 3x minus 10. And of course, I'm going to subtract the 3x, leaving me with 2x. Negative 2x equals negative 10 divided by negative 2, giving me x equals 5, and that's my solution. So I was solving for x. I solved for x by condensing my problem. As you can see, it was really long, and I used basically all of my properties. I used the product property, I used the quotient property, and I used my power property as well. That was actually my first step. is to get rid of those coefficients and put them up as exponents and then simplify them that way. That got rid of them. So, go back and review this, rewind this video and watch this problem. This problem had all three different properties shown in one. Now let's move on to another problem. Here's the quotient. Our quotient product, our quotient property, which is log base b, a over c equals log base b a minus log base b of c. Okay? And so you'll notice that I have a specific part of my term highlighted because the highlighted part indicates my a and my c. And you'll notice that they are separated by a subtraction sign, by a subtraction operation. So that means I can then use my quotient rule, which is what I have highlighted up there, of course. Now something else that you might notice is that there is no base. You don't see it. Let me take that back. Not that there isn't a base, but you don't see it on there. This is like having an exponent with, like if I have an x, then you always assume that there's a 1 in front of that x. Okay, so it's an assumed 1 whenever you see a variable standing by itself. Well, whenever you see a logarithm standing by itself with no base, there's actually an assumed 10. So it's actually log base 10 that you see. And so this is my complete problem at the bottom, log base 10 times my term that you see there. So since I have a log base 10, what I want to do is I want to solve for x. So I want to get rid of my logarithm then, and I want to reconvert or go back to its exponent form. Okay, so if you remember the formula or the what you had to memorize to exchange exponent to logarithm and logarithm to exponent form, I do have a video that highlights that. That's the first video on logarithms. So go back and watch that if you don't remember this. So that log base 10 is my base, and the 1 on the right side is going to be my exponent. So I end up with 10 to the first power, which is basically just 10. So now I have just your run-of-the-mill algebra problem. And I'm going to multiply by x minus 3 to both sides. That cancels it out on the left, but gives me a 10 times x minus 3. So I'm going to clean this up a little bit, give myself more space, move it up to the top, and then just solve algebraically. Okay, distributive property, 10 to the x and the negative 3 gives me 10x minus 30. I'm going to add 30 to both sides, and I'm going to subtract x to both sides, giving me 36 equals 9x. And of course I will divide by 9, giving me x equals 4, and that's my solution to that problem. So again, I had this really long complicated logarithm, and I used my quotient property, okay, to condense it and then solve it from there. All right, so again, these are my three properties. I'm going to work out one more problem that will highlight all three properties. There it is. L of n is the natural log of 4x plus 3 times natural log of x minus 2 minus 2 times, and then I have 2 will be distributed within this term here, natural log of 2x plus natural log of 3n minus 4. Okay, so let's work this out. This looks kind of confusing. So the first thing I'm going to use is my power property. I have two coefficients, the 3 and the 2. I'm going to condense this. So the power property tells me that I can actually convert this now and distribute that coefficient as an exponent. Notice on the right side of my minus sign, that 2 is going to be distributed within those two terms on the inside. So take notice of that step right there. Okay, so what I'm going to do next, I'm going to simplify. I'm going to simplify natural log of 2x to the second power, distribute that exponent to the 2, which gives me 4, and then x squared. So I've simplified that. And now you'll notice that I have a plus sign on both sides. So that plus sign will now allow me to use my product property. So I have natural log of 4x plus natural log of x minus 2 raised to the third power. I'm going to condense that and put that together. And that will end up with natural log of 4x times natural log of x minus 2 to the third power. And likewise on the right side, I end up with those two terms that I had. In fact, you can see the step previous to that. You can see what happened there. Now I have them both under one natural log symbol. So now I'm going to turn my attention to that minus sign. That minus sign will allow me to use now my quotient property. Quotient property stating log base of b a to the c equals log base b of a minus log base b of c. So you'll notice here that I'm working backwards now. So if I'm focusing on the bottom parent equation, I'm going from the right side to the left side, right? So here goes. See what happens here. So that means I will be dividing the top, or the left side, by the right side. And there's my new formula there. Okay, natural log of my term on the left over my term on the right. Okay, so again, feel free to pause this video so you can kind of really analyze what's happening here. And what I'm going to do next is my final step. I will simplify. Okay, and there's only really one thing I can do to simplify this, and that's the 4x over 4x squared, and that will leave me with a single x term on the denominator, and that's it. That's the problem simplified, and that's my answer right there. Okay, well, that does it for this video for logarithms and using the 3 main properties for logarithms. Okay, good luck in your studying.